Hello everyone, this is Hossein and this is the tutorial video for Siemens NX manufacturing focused on mill turn machining. In the first part, we're going to go through the setup of the part, and in the next videos, we're going to focus on the implementation of operation and visualization of different steps. Similar to turning machining, we have three big parts. We have the first setup, main program, and then the output. First setup. In the beginning of the setup, it's always good to check the diameter and the length of the part to know that, okay, what kind of a geometry we are going to work on in case we need to define the blank and so on. So we're going to first analyze the part, measure the distances of the length of the part and the diameter. And then after that, we're going to go and select the manufacturing tab. We're going to go to the mill turn section, and then we start to create the different geometries. Note that in this specific tutorial, we have a machine that has two spindles, and that's why we have a main spindle and another sub spindle. And then similarly to turning exercise, we will go through different geometry definitions, avoidance, and then different machine coordinates system, and also the containment defining the spindle chunk. So in the first one, we will go and create the sub-spindle assembly, and you can see that we have two parts. It's basically the one part is our main part. We're going to go through the definition of seven main operations, and after that, the part is going to move to another spindle that you can see, for example, on this picture on the left-hand side. The second part is actually on another spindle, and then we're gonna go cut the part and also do the another facing so that we have the file finalized. To do so, we need to create another copy of the same part in form of assembly so that we have two components, and after that we're gonna define what are the different planes. So here we need the Z or ZX in the machine, so ZMXM plane. So note that this type of a machine that we are going to use is as I said, have two separate spindle. The main spindle is on the left side. We're gonna define most of the operations. So in this case, 7 operation on this part. And then the part is going to be transferred to the second spindle to able to finalize the other part, the other side of the part. Then after that, we're gonna go and create our shaft or our raw stock material. As I said earlier in the previous video, either you have the chance to define the raw stock part separately on a different assembly, or you can create it directly when you are defining the operations. And in this one, we are defining it right away as a form of a geometry, which is now, because it's a simple cylindrical shape, and we're going to make it transparent so that we can see the parts inside it in a sense. Then after that, we're going to go and define the workpiece on the main spindle. So you can see it's the main spindle on the workpiece. We're going to define where the part is located. Similarly, where is the blank located, and also defining the material. After that, we're going to move to the sub spindle. So the second spindle that was on the right side, specify what the part is. And for that one, we also need to define the specify blank boundaries, which is on the workspace, and then automatic positioning of the part in the spindle. After that, we need to define the avoidance and containment planes. Avoidance is basically defining where the part is and how much or where are the locations that the cutter can move safely in order to machine the parts to reach the final desired geometry. For that one, we need to just double click on the avoidance part and then defining the starting point of the tool. And then the part will be considered as an avoidance. And then for the containment plane, we need to define a plane, like let's say a parallel to the ZX plane of the machine. Like for example, in this specific case, is defined 5 millimeter after the part. So we are considering that all these parts are 5 millimeter after the end of the component that we are aiming to reach. Then we have the chunks that is going to be clamping the part. So in this case, the containment will consider that the tool does not move after this plane, so that we avoid any unwanted collision with the spindle. So it is actually similarly to the turning video that we had before. We need to create the geometry with the containment and then define it with the different distance that we would like to keep. So here is the configuration. You can check the video here in case you are not familiar with this type of a machine, and it actually shows you a good example how does the machining on two spindle machine is look like. So again, here just to make sure that we understand each other better. So we have a main spindle on the left-hand side. The component is a raw stock is there. We're going to define not 7 machining operation, different operation on the part so that we can reach this blue part inside the raw stock. And then here is the containment plate on the main part, and the similarly same containment plate on the other side of the component. And then on the right side, we're going to finalize the part by going to define the cutoff and facing operations. And you can pay attention to the containment plate plane positions. So one of them is like 5 millimeter after the intended final surface on the left side of the component. And then after that, the other containment for the ease of assembly, we are defining the center points of this hole as a maximum area or a maximum zone that the cutter is allowed to go without collision with this window. Then after that, we're gonna define also the different avoidance now for the second part or second assembly. And the avoidance is basically the starting position of the tool itself. And on the right rectangle, you can see that the center of the circle hole that we have it here, that is shown with the point with yellow with the boundary of red. And this is the point that we are defining the containment on the sub assembly. As the last step before going to create the tool, we're gonna go and create, and we're gonna go and hide the main component so that we are able to see the final component for the ease of definition. We can define and create the tools when we are actually creating the main component. But then here, just to get to know how does that definition of a tool works, we can also define a tool. And for example, here we are defining the Z direction milling tool, for example, before we are defining the main programs. And here is to how to define the shanks and also the holder of the parts. And even you can even search from the library of NX to load the component, for example. And then you can copy and rename the parts as it is needed. All right, before we go to the second part, I'm gonna now switch to software, and we're gonna develop the same things step by step here. So the software that we are going to work is this NX CAM. So now I'm going to just open the part, the mill turn part. I will just open it here. This is the part that we are going to have. You can see that the majority of the features can be done with the normal turning. However, these slots here, the slots in the center, and even these holes are the one that are justifying for us the use of mill turn machine. So what I will do, I will just go File, New, and go and define the manufacturing. So the manufacturing tab, I can see that the units are millimeters, and we are going to define mill turn essentials. I can define where the part is located and even calling the part. So these are important if you are not gonna, if you don't want to use your work halfway. After that, they're going to go and enter these manufacturing modules. If you need to change something in the part geometry, you can always go to your application. You have the access to the modeling settings and even to the assemblies. Either you can find the assemblies here in the application, or now I have it in a different setup here. And if you go to the home, then you have the comments for the Miltern definition operation. All right, so the first step, if you remember, was just able to measure the different diameter and then the length. So for the length of the part, I just type measure. I'll search, I'll put this point, and then if I wait here, now this three dot will appear, and I'm able to find the face behind that. So I can see that the component that I'm going to work with has 32 millimeter length. And then if I just wanted to measure the diameter, again, I'll show it here. And then if I just click here, I can see that the radius is 21. So diameter of 42 is the one that we are going to use with it. So now these are the values that is help me to defining the raw stock material. All right. Now what we need to do is to actually create the geometry, going to the different views here. So I can again define it here. So again, we can see we have similarly to the turning one, we have the program order view that we have all the list of the operations here. Now it's empty because we still didn't start it, the activity yet. We have the machine tool view. You can also access different view by right clicking here, or you can just refer to these icons here. Now I have the turrets that is open. I have two predefined tools, both outside diameter cutting, and then by double clicking those ones, I would be able to change the parameters here and even the holder and shanks and holders and tracking and so on. In another tab, I have the geometry view that by putting this, clicking on this sign bar, sign, the positive sign, I have now open. Now I can see that I have two spindle. In case you only want to define a mill turn operation only using one spindle, or your machine has only one spindle, you don't need to definitely define this sub spindle, so you can just ignore it. In case you are using the configuration of the machine with two spindle, then obviously you need to define the both geometries. Before we go back here, we come back here, we'll just show you that we have also this machining methods as well here. All right, I go back here and then just show you how does this look like here. So I click first on the main spindle, and you can see that here I have the main workpiece, I have the turning workpiece, and I have the machine coordinate milling and hole making. I can even still open this area, and then I have the avoidance of the main spindle here. The same type of a structure I have it for the sub spindle, obviously. So these are the ones that I'm going to define one after each other. So the first one, the first step was actually to create this a copy of this part. So what I will do, I will go to the assembly tab. I have it up here. If you were not able to find it here, you should be able to find it in an application. I go to assembly, and now I want to basically add another component. So I will add another component. Either I can just now reload or open another file by choosing a file select, or I can just click on an existing component and saying that I will have another one with, let's say, toward x-axis. For example, let's say if I put 100, what will be? So now I have the second component appearing here. So I will just click OK. in case you had the trouble to figure out where the part is, or you couldn't see that because perhaps you were zoomed in or the value was entered was big, you can always go and put the command fit so that it brings it all to the picture or to your screen. Next, what we need to do is to move the subspindle machine coordinate system to subspindle part. And for that one, we need to again go back to our home so that we go again to the mill turn one. And then we go now to the machine coordinate system in the subspindle. So we have the subspindle here. And then I have the machine coordinate system in the subspindle. I should have it here. I double click on that one. And then again, similarly to turning, you should pay attention that the axis of your shaft is now giving you the axis of the machine. So this M is stand for the machine, the Z of the machine. Or in a sense, the plane should look like this. If not, then you should be able to rotate it so that it fits better and as you are wishing for. So now what I would like to do is actually to specify this coordinate system. Pay attention that this is on ZX plane of the machine itself, and then clicking here. And now I need to define it here, and to be able to define it clearly, I will just say, if I can use infer. Oh yeah, here. So I need to work it with the entire assembly. Otherwise, it will only letting me select the part, select the points on this one component. However, this is a second component, so I will just activate that the selection will be active on the entire assembly. And after that, I can see if I can use the different scenarios here. So for example, now I want to just get the center here. If I can find it, let's see what will be having it here inferred. And now I can see that the center is perhaps suggested. Let's see. It looks like it's okay. We're gonna move forward and see that if everything looks fine, but it looks like that the ZM is on the correct direction and on this plate, so I assume that everything looks fine here. All right, then after that, just to make sure everything looks okay, I just click here, orient view at top, so I should be able to be on this plane, which is now correct. Next step is to define the blank geometry, raw stock geometry, which is in this case just a simple cylinder. So in that case, I can just go to the geometry and create cylinder, or I can just type it here. Let's try to see that if by typing it I get what I want, for example, then it would be easier for you also to figuring out how to find these comments. Sometimes these tabs are changing here. So knowing that what are the values of your part, so I will define the diameter of, let's say, 45 and height of 55. I'm not interested to have any Boolean here. And now the position, for example, I can get the axis, for example, vector, let's say, x-axis, if I can choose, if I can find, yes, x-axis of the component, so the axis is correct. And now let's see if I can just click here, for example. And if I again go to the orient view, I want to allow some 20 millimeter from For example, I can put now 0. So 0, it would be here. And I want to have 20 millimeter extra material on the left side so that I would be able to clamp it with the spindle choke. So now I put what will happen if I put -20. Now it looks like from here the spindle, the raw stock would start. Let's see how does that look like here. It looks like it would be correct. I don't know why there are two. Anyway, let's let's go move forward. When we are defining the transparency and then hiding the part, then we are able to see that what are these two components. I have the feeling that there are two components now creation, so we need to remove one of them. But that's not a big deal. We can do that. So to be able to visualize the part here, so I'm not able to right click and just define the transparency here as some software allows me. So what I need to do is that I have the menu here. I go to menu, edit, and then after that I go to the, oh sorry, menu and preferences. And then I have the visualization somewhere here. Well, this is not quite what I'm looking for. Let's see, visualization. Here, the point of coming to visualization is to be able to check that we have the um, that the software is allowing us to define a translucency. So I think that should be fine, even though now I don't find it here quickly. But let's first define the transparency. And if it didn't work out, we will come back to this visualization again. So now I go to File, Edit, and then Object Display. So File, I'm sorry, Menu, Edit, Object Display. I click OK, I select the object. Yes, so now I can see that now mistakenly two objects are defined, so I can get rid of one of them. I will define this one, and now I'm able to define translucency. For example, I can put something like over 50, then it should help me with the task itself. So now I have this part and I need to get rid of this one. So knowing that this component is defined in an assembly, I should be able to find it in an assembly navigator or in the part. Now I can see that there is cylinder part, so it was in the part navigator. I have the cylinder 1, which is my correct one, and the cylinder 2 is something that it's in vain. I just delete those ones. Now I have my part inside the blank itself, knowing that this value is 20 millimeter. All right. Now in this step, we need to define the part geometry on the main spindle, for example. So again, I go back to my operation navigator. I go back to the geometry view, and now I'm working on the main spindle. On the main spindle, then I have the workpiece main. By double clicking on those one, this is the familiar part that it comes. So I just specify the parts by just clicking here and then clicking my component, which is this one. Clicking right. Now the part is defined, and then I can also right away define the blank also. So I'm defining the blank. That's it. Or if you remember last time, we have actually created blank directly from here. And then if I have any specific chart, specific geometry to avoid collision, then I need to define it here. Otherwise, then it's fine. Then obviously we need to define the material, for example, here. Well, let's choose, for example, a material of stainless steel, for example, or whatever material you are basically using. All right, now we need to define the same one on the sub spindle. Again, I repeat, if you have only defined only one spindle on your assignment or on your in your projects. Basically, you don't need to now follow this step, but now in this specific example, we are working for two spindle. So we need to define the workpiece on the sub spindle as well. So I just double click this one, and then, sorry, on the workpiece, I just step one step forward, one workspace here. This is my geometry, and this is all right. All right. So now the question is that how to define the extra material that is available for this second part. So as I explained earlier, all seven operations that are needed that are defined on the left side, and on the right side component, there are only cut off and then the finishing of the part, of facing of the surface here. So we don't need to define a different blank or geometry in this specific scenario. But of course, if we had a totally different type of a geometry defined here, as you could see perhaps on the video of the YouTube that I put the link, in that sense, then you needed to define the blank. But for us, in this specific case, we just need to define it as an automatic positioning here. So I just double click on the turning workpiece sub or sub spindle. And then I will select the specify blank here on this icon. And then here, let me see, or did I click correctly? Specify blank boundaries, sorry, blank boundaries, this one. Yeah, that's why I was a bit surprised um, what was the next window, the previous window that was appeared. All right. Anyway, then from here we choose the workspace and we click the automatic positioning. And that's it for now. What we need to do next is to define the containment plane and also the avoidance. Where does the tool start for both of these spindle, and also where are the position of the spindle chuck so that we avoid any collisions. So again, we go to the main spindle. We double click on the avoidance main. From we open this one from point or FR, and we specify a position here. It can be a very accurate position, or for us it's just the somewhere far from the raw stock, basically on top here. And then that's about it. And then we can define the same one on the main spindle, but now that we are on the sub spindle, now that we are on the main spindle, we will finish everything here. So the next step is defining the containment. And you can see that the containment geometry is not predefined here. So what we need to do is I go home and then click geometry. And then here I need to look for the containment. Here is the containment. And then, of course, it will happen on the avoidance on the main. And containment, for example, I can call it, I don't know, main or one or something that I can uh, find it easier. So I put containment one, and remember that this geometry needs to be applied on the avoidance main, so on the main component. After that, I click here, and now I need to define a plane similar to the PowerPoint that I show you, a plane parallel to ZX plane. So I will just put it will be axial plane trim 1. So I would just I could define a point, I could define a distance. If I put 0, it means that the tool will not move after this one, which could be fine, but then again, I can put a little bit of more material so that I don't have any problem of extra material left here. So I can put, for example, -5. And that's about it. So it means that 5 mm of the part should be out, and then I can see how much part should be out from the surface of our raw stock to the point of the that the chalk maximum is going to be clamping the part. So that's it. Now I click. Now I assume that yes, another geometry added here, containment plane. We're gonna go and do the same on the uh, sub-assembly. So first one was the avoidance. Avoidance is already existing here. From point, I click specified. Similarly here, I click a point here, and then that's it. So this is defined here. And then for the containment plane, if when I show it on the um, file here, I just bring it up here just to remind you. You can see that now I have defined it on the passing on these points or middle points of this circle for the simplicity. So I go back here, create another geometry, and now this one on the avoidance sub, and I can call it on the sub part, containment, and then try to define the for example, now we don't want the this, or we could define a distance, for example, but now just to practice something else, I can put for example, trim plane 1, but instead of having a distance, I can define a point to be specific on this one. But I could also define the the plane, the distance also. So for example, if I put 5, it would be here, so it would be, for example, -10, or let's say -20, or actually looks like that is more or less -15, but to be more accurate, I would like to just define it by point here so that I know accurately where the point is. All right, so now I have defined what are the workpiece of on the main spindle, on the sub spindle, what are the avoidances and containment geometry. Now before finish up this step, now we need to get rid of this component or hide this so that we would be able to work on it better. So for that one, I go to menu, but this is not necessarily needed, but it's maybe clearer if you do that. So I go edit, and then I can go hide and show, which is here, and then show, hide and show the part, and then clicking the hiding the part, because otherwise, let me try. Yes, otherwise I cannot able to do that here, or I can go to the part view, right click on this cylinder, and I can also hide it here. So this is another approach to do that. If not, then I should be able to find it here. File, edit, show and hide, then hide component, and I put the hide here. So now I have the part to be hidden. Now I'm ready to define, for example, a tool before we end up this video at this section, this part. So currently I have these two tools that are defined, and I will define another tool, for example, in station 2. Create tool. I will create a milling one. And then, for example, I can call it exactly what is this milling part look like, so that I would be able to defer different milling tool if I need to, for example. So I will just correctly naming it. Now this is how the tool look like. I will just put the value that it was suggested by the tutorial, diameter of 5, length of 30, and the flute a length of 20. Now this is my end mill. Of course, the end mill is connected to the shank, and this is something that you need to either decide it here, either see that what are the shanks that are available in the workshop, or what are the shanks that it is used basically on the workshop by your operator, and it's better to define it exactly that one so that you can make sure there wouldn't be um, any unwanted collision. So the shanks geometry would be, this is the shank. Um, let's see, let's say the lower diameter would be, let's say 20, upper diameter 20, the length, for example, 50. That would be either is this one, or you can even give it a taper angle, for example. Otherwise, there should be a problem here. I think it's this one. For example, something like that, taper angle 20, upper one. Oh, okay, this is defined. So this either you need to define this or this. So 20 I put for the diameter, then the length 50. What will happen if I put this one 20, for example, something like that. And then after that, I have the holder. I can again either define the holder value here, or I can actually go and retrieve it from the library, for example. I think something that was shown in the tutorial was just getting it from the library here. And I don't know now which one will work here, but something like that, for example. And then you still have to choose the offset. So, for example, what will happen if I put offset 0? So there wouldn't be any connecting point between this holder and shank. So the more this value it will be is the amount that is going to be inserted inside the holder, and it will be clamped here. So for example, let's keep it as it is. And let's click OK. So this is my tool, or actually I have also forgotten to define it in a correct tool station. Let me define it again. So now you can see that I forgot to put it in a specific station and it's out of the turret, which is not good. I will just create a tool again here, and here is the one that I missed. I put it in 1, mil 1, and then what was the value? I put it here. I put length 5, and then the length would be 30, and the float would be 20. I can choose the number of float, for example, it can be 2 for now. And then just quickly defining the shanks would be 20, and then the upper taper, the angle is 20, for example, and then the length would be 50. This looks a bit bizarre. And then the holder, I went and defined it on the library. And for example, something like this, that it fits to the part. And then I could define the offset as much as it would be necessary. All right, so now I have a tool correctly. I could even copy this one and then go to the station number 4 and then paste it this one, and then I can rename it, for example, here, that this is mill number 2 in case I want to use similar type of a tool, but there would be some kind of a minor difference. By double click, then I have the access to change these parameters, for example, here. All right. So that's it for this part. I will now pause and go and start making a new program of the main program. Thank you.